Dear friends, till now the dropper portion practical example is due to upload. So today I am uploading it. Here first I have shown the uneven encumbrance. That means the first mast encumbrance is 1.4 and the adjacent mast encumbrance is 1.2. And what will be the dropper length that I have shown in the picture. What I have done, I have done E1 minus E2, that means 0.2 divided by the span, that is 72 divided by 72, and the distance of the dropper to be multiplied, and at that distance the dropper length for even span minus this E, so that it will give the accurate distance. The first dropper here after 2.5 it is showing 1.2656. The second dropper after 6.75 it is showing 1.050. The third dropper it is after 18 meter, so it is showing 0.638. Then fourth dropper it is showing 0.439. The fifth dropper it is showing 0.356. The sixth dropper it is showing 0.389. The seventh dropper it is showing 0.538. So this is the system where there is uneven encumbrance. One side is 1.4 and another side is 1.2. Then you have to follow this system. What is the system? The actual dropper length for 1.4 encumbrance both sides to be the value of E to be subtracted from each dropper length. The dropper length is varying with the varying the distance. It is from the first mast it is 2.25, then 6.75, then 18, then 20. So in this way it is moving. So you can find it out easily. So I have shown the even encumbrance, the uneven encumbrance, the changes case of span. So almost it is over. Try to understand it. This is required where uneven span is there. At that time the dropper length to be calculated. In the field they are not doing it roughly, they are adjusting it by their experience. But if you try to keep good OHE profile, you have to calculate it and maintain that length. Especially for new OHE, it is the commissioning time, so maintain accuracy. But in the breakdown it is not possible to restore it with accurate profile due to the shortage of time. We have to give fit the OHE for normal traffic, so we are not getting time. But for new OHE you maintain this thing. Even where is the encumbrance is changing, where we are approaching to a tunnel, approaching to a overland structure, approaching to a foot-over bridge, we are reducing the OHE height and the encumbrance to permit. But keep it in your mind, the minimum length of the dropper in the minimum length, minimum encumbrance must be 300 millimeter, and the midspin dropper should not less than 150 millimeter. Between the two masts, the middle dropper should not be less than 150 millimeter. Here you can see that no dropper length has reduced from 300 millimeters, so it is acceptable. Though in the field we are managing it, but try to keep it. So how we have find out the E when the uneven incumbents there? I am showing it in the next slide. Friends, here I have shown how to find out the uneven incumbents Doppler length to adjust or subtract from the even span Doppler length the value of E, that is 1.4 the first span minus 1.2 the second second mass span divided by the span of parameter meter. That means per meter its deduction it will show, and then multiply it with the dropper distance. The first dropper is 2.25, second dropper is 2.25 plus 6.7 is equal to 9 meter. In this way it will proceed. So up to this the dropper. Any query, please contact 9163857152. Again 9163857152. Good morning, friends. Happy Dasera. The situation of our country in Bengal and in the world is really critical. Now the evil power has been raised high, and so many incidents, unusual incidents are occurring. People are suffering. So we must kill the Ravana, the evil power. The general people are suffering, and who are in power, they are misutilizing it and killing the general people. So we need Dasera to kill the Ravana. Now we are giving an introduction on relay, especially numerical. Already I uploaded a video on relay. It was the basic. Now we will discuss about relays and its setting in details. A numerical relay is a computer-based system that uses microprocessors to detect electrical faults and control and protect electrical systems. They are used in industrial, in railway, in utility power transmission and distribution system, etc. Numerical relays are more accurate, reliable, and flexible than traditional electromechanical relays. They have several advantages, including programmable. Numerical relays are programmable, so their characteristics and behavior can be customized. Multifunctional. They can perform multiple protection functions in one unit, as well as provide metering, communication, and self-test functions. Advanced features. They offer advanced features such as event recording, self-diagnostics, and communication capabilities. Easier settings adjustments. Numerical relays are easier to adjust than traditional relays. Better integration. They integrate better with modern power systems. Numerical relays are used for tasks like overcurrent, differential protection, distance protection, wrong phase coupling, they also integrate the all protection relays for power traction transformer also in one unit or two units. They also provide high voltage protection incoming side, that is overcurrent relay, identity and instantaneous earth fault relay. In the transformer LV side also they give protection over current, earth fault, and for transformer all delays. Transformer protection all delays. For feeding side it is giving over current relay, PT protection, under voltage, over voltage, delta I protection, distance protection, wrong phase coupling protection, pinto flashover relay protection, and for capacitor bank also it is giving under voltage, over current, neutral displacement relay, PT fuse failure relay. So many things can be combined or integrated in a small delays in a small unit, and it will give all the as it is microprocessor based, it is programmable and can perform so many functions, so it is multifunctional. So friends, let's see how we are protecting our traction substation.